There are many different ways for us to determine the solution to a system of equation. One might be to graph it, but we can do it algebraically, and this first method we're going to talk about is to solve a system of equations by substitution. So these are the two examples we're going to look at. This method to solve by substitution asks me to solve one of the two equations that I'm looking at for a particular variable and substitute it back into the opposite equation. So I have 1, 2, 3, 4 variables that I'm looking at here. And this one is actually pretty straightforward because you can see of my two equations that are listed, the second equation is already solved for x. So all I have to do is take this second equation, which I know x is equal to 2y plus 1, or 2y minus 1, and substitute into the first equation what x is, and that's substitution. So we're going to look at this and we're going to say, okay, so I'm going to let x be 2y minus 1. And I'm going to get into the habit of surrounding it with parentheses, just in case I miss a sign. And then we're going to say minus 3y equals 7. So what I did is I substituted the second equation into the first equation. And now I created an equation here that is in one variable. It's all in one variable, and I know how to solve this from previous experience. So I'm going to get rid of the parentheses and collect like terms. This is simply 2y minus 1 minus 3y is equal to 7. Collecting my y's, I find out that we have negative y minus 1 is equal to 7. And I am going to add 1 to the right hand side, so negative y is equal to 8. And then I've got to divide both sides by a negative 1, or we'll just change this to a positive y and a negative 8. Now that I know what y is, I am going to take that value and I substitute it into the equation not the equation I just used. So instead of the first equation, I'm going to substitute into the second equation to solve for x. So we're going to bring that equation down here. That looks like x is equal to 2 times a negative 8 and minus 1. So x would be equal to negative 16 minus 1, or in other words, x is equal to negative 17. So the solution to this equation is the ordered pair represented by negative 17, negative 8. So again, the idea behind substitution is I am going to, of my two equations, I'm going to solve one of the equations for a variable. I decide which variable I want to solve for, and then substitute into the other or opposite equation to get a different equation all in a single variable. This one was, again, easy because it was already done for me. And the solution is the ordered pair. Now let's do that to this set of equations over here. Again, I'm trying to follow the substitution method. So if I look at my 4 variables that we have right here, when you're looking to use substitution, if it's not already solved for you, I'm going to look here and I'm going to choose, if I can, I'm going to choose one of the variables that has a coefficient of either a positive or a negative 1, because that is going to be the easiest equation for me to solve for y in. And you can see here that I have this variable right here. This y has a coefficient of 1. There's a 1 sitting next to it. So it's going to be the easiest one for me to solve for without introducing fractions, because I know we all love fractions, without introducing fractions into my equation. So I'm going to take that equation, 3x plus y is equal to 2, and I'm going to solve for y by subtracting 3x to the left hand or to the right hand side. So y is equal to negative 3x plus 2. Now it could have been y equals 2 minus 3x, and it's the same thing. I just like sticking my variable x next to the equal sign because it makes me happy. So I've solved the second equation for y, and I am going to plug it back into the first equation, and I am going to plug in what y is into this y from the first equation. So this looks like 6x plus 2 times 3x, negative 3x plus 2 equals 7, giving me an equation here in one variable that I know how to solve. So we're going to distribute to get rid of the parentheses. I get 6x minus 6x plus 4 equals 7. I'm going to gather my like terms up over here on the left hand side, and I get 6x minus 6x. That leaves me 0, but I still have 4 is equal to 7. Now, does 4 really equal 7? No, it doesn't. You're saying to yourself, what happened to my variable here? Well, 4 does not equal 7, meaning this is a false statement. And when we get a false statement algebraically like this, that means we have no solution to my system. Now remember, we had 3 ways that we can get a solution. One solution, which was what we had over here, the ordered pair. And this is an example when we have no solution. No solution meant my 2 lines should be parallel to each other. So if you get that algebraically, go back and kind of look at your lines and determine, either using a graphing calculator or looking at the slope, to make sure that they are parallel. So let's look at it for just a second. If I take this first equation here and solve it for y, that looks like 6x plus 2y is equal to 7, or 2y is equal to negative 6x plus 7. Divide everything by 2, I get y is equal to negative 3x plus 7/2. Now, we should remember, and if you don't, it's okay, but what I hope that you remember, let me get a different color here. It's the color I want. What I hope you remember is that this is the slope of one line, this is the slope of the second line, and because the 2 slopes are exactly the same, then that means that the 2 lines are parallel. So same slope means parallel lines. And that way, when you're doing this algebraically and you get this funny sort of solution right here, or a false solution, you can kind of quickly go back and check, yes, those are parallel, and that is the answer that I should be getting. And this is one of the ways that we can solve a system using substitution.